All right, good evening, everybody. We're going to be doing the homework assignment for complementary and supplementary angles. We can remember that a complementary angle are two angles that equal 90 degrees. Supplementary angles are two angles that equal 180 degrees. So let's work from there. This is our rules that we're using here for these two type of angles. Keep them in mind. All right, so number 17, I'll do first since I'm doing the odds. We know that every right angle equals 90 degrees. So we're talking about a complementary angle here. We know that because we have 90 degrees being split up by a ray, which means we have two adjacent angles, right? So this is going to be complementary. Okay, let's go to number 19. It says angles J and angles K are supplementary. All right, supplementary. That means there are two angles that equal 180. Okay, so let's just go ahead and say that we have a line here and two angles that equal 180. Okay, that would be a line splitting them up. The measure of angle J is 9x and the measure of angle K is 45. Well, we're going to put angle K over here. That equals 45. And we're going to do, this is angle J. And that equals 9x. What is the value of x? Well, since we're talking about a supplementary angle, we know that these two angles have to equal 180. So we can write out the equation 9x plus 45 degrees has to equal 180. Oops, sorry about that. And now we're ready to go. Well, first, this is a two-step equation. We do PEMDAS backwards, which means we're going to do addition and subtraction first. There's our addition sign, so we're going to find the opposite of positive 45. That's negative 45. Whatever I do to one side of my equation, I have to do the other. 180 minus 45, well, that's going to give me 5. Borrow one for that. It's going to leave me 3, and that tells me that is 135 equals 9x. Now I have to figure out how to get 9 away from x. Well, I'm going to divide 9 away. Whatever I divide from one side, I divide from the other. So now I have 135 divided by 9. Let's put that in our calculator. Well, 135 divided by 9 is 15. So that means x equals 15. That's pretty easy. All right, let's move on. We're going to go to number 21. Okay? 21. Determine whether each statement is always, sometimes, or never true. Explain your reasoning. Two obtuse angles are supplementary. Well, let's remember here, obtuse angles, okay, are angles that are bigger than 90 degrees, okay? So they're saying two obtuse angles are supplementary. Well, if I have two angles that are bigger than 90 degrees, let's just put one here. Here's one angle that's bigger than 90 degrees. And if I try to combine it with another one that's bigger than 90 degrees, okay, well, I know that, let's see, a number greater than 90 and a number greater than 90, can they possibly equal 180? Well, that's impossible. You see, 90 plus 90 equals 180. So if I'm dealing with two angles that have to be bigger than 90, right? Like I said, I don't know what these angles are, but I know they have to be bigger than 90. Then they can't be 180. They have to be, well, they'd have to be 100 and maybe 81 or 182. I mean, if this was a 90.5, I mean, no matter what, it's still going to be bigger than 180. So this one is never true. Never true. Okay, and I think it's a good time to go ahead and get the code word out of the way. I'm going to write the code word down here for the week, and I'm going to say the code word is going to be, well, we just had the Super Bowl and the Patriots won, so we're just going to say Patriots won Super Bowl. Okay, so there we are. That's our code word. I'm going to go ahead and erase it now, so no one will know what it is. And let's go ahead and finish off our homework. We're on number 23. A line A passes through 1 and 4 and -4 and -1. Line B passes through -3 and and 4 and 2 and -1. So let's go ahead and mark these coordinates on our graph here. 1 and 4, well, remember the first number is always x, so this is 1, and then 4 would be 1, 2, 3, 4. This would be our first coordinate. Our second one's going to be -4 and -1. Well, -4 is way over here. 1, 2, 3, 4. And -1 would be here. So this is going to be our first line, okay? The second one says line passes through -3 and 4. Well, 1, 2, 3, and 4. 1, 2, 3, and 4. That would be here. And 2 and -1. Well, it says 2. That's 1, 2, and -1 would be here. So we'll mark that here, and we'll put our next line there. All right. Now it says A, graph each line on the same coordinate plane. We just did that. It said describe the lines. Well, if we describe the lines, we're going to say that the lines, I could say that they intersect, right, here at -1 and 2, right? So let's type here, the lines intersect at -1 and 2. The other thing that we could say is they really appear to be perpendicular, don't they? Right? Because this line here goes over 1, down 1, over 1, down 1. So that tells me that the slope is going to be, let's see, remember our line is going down, so that one is going to be a negative slope, right? Negative slope. And let's put it down here next to it, negative slope. And it's going to be down 1, right? And over 1. Okay? And that's going to be a slope of negative 1. The other line here seems to go up, so it's going to be a positive slope, right? Positive slope goes up 1 and over 1, up 1 and over 1, right? Rise over run. And that's going to be 1. So we have negative 1 and we have 1. That indicates that this is going to be totally perpendicular, all right? So the next thing we could write is lines are perpendicular, all right? All right, now number 3, or letter C says numbers. What is the slope of each line? Well, we just came to that determination, didn't we? We know that, let's see, one line has a slope of 1, and the other line has a slope of negative 1. And, well, that is the entire homework. So, guess we're done. Thank you for listening, and I'll see you in class.